Um, as we say, our goal is to make a short video, but where we are going to explain the concept very well so that when you come across any type of problem, you can be able to solve it yourself. So I decided to put question 2, 3, and 6 under your tutorial 5 together so that you can understand what the difference between the three. And it's all about a projectile object. So we're going to have a look on question 2 first, and then we'll discuss question 3 and as well question 6. The concept is similar, but the approach is just different. Okay? So let's have a look and see what does our question 2 says. Question 2, they say airplane. The airplane, which means we're having an airplane which is flying and drop a package from the air. Okay? So this package, when it was dropped, this airplane was moving at a constant velocity. So the velocity of the plane and the velocity at which this package was dropped is going to be the same. I'm moving at a certain velocity and then I drop something. Basically, when I say the initial velocity is going to be 140 kilometer per hour. Okay? And then they said this velocity is constant. So first of all, we need to change this to meter per second. And then if this velocity is constant, what does that mean? It means the acceleration as well is going to be constant. Okay? The acceleration in x is going to be constant. And then when we say the acceleration is constant, x is going to be equal to 0. First information that we can collect. And then they said this package was approached the spot at an altitude. Altitude, which means from the ground to where the plane was flying, we have a specific altitude, and it's given at 0.5 kilometer. So we need to change it as well to meter, and then this we're going to consider to be our y because we are in the y axis. Okay? And then they say calculated the horizontal distance. The horizontal distance, we want to calculate this distance from, okay, between the point when the package was released. So for instance, if this package was released on this point, okay, on this point there, okay, and between this point when it was released until the point that it's landing, at the landing point. So we are looking for the x-axis, okay? So what did I say about a projectile time? We say a projectile time is the time, a maximum time required for us to drop something from space until it reach the ground. So that's gonna be the projectile time. Okay. So this projectile time, we say at the projectile time, our altitude is critical to 0 because once we drop something, once it reach the ground, so already y is gonna be equal to 0, and therefore our final velocity in y is always going to be also equal to 0 meter per second. Okay, so you can see that. But remember, we say when you drop something, okay, the acceleration in y is going to be the same as the gravitational speed because we are in the air, Newton rules. Okay, and then therefore it's going to be given by 9.8 milliseconds squared. Okay. But we put a negative here. Why that negative, as I explained, is because we are dropping an object from the air. Okay? So we're going to take again our 4 given formula for those equations for kinematic into dimension. So we're going to using the one from the y-axis and from the x-axis. And as I said, we're just going to choose one according to the given value that they give us. Okay? So let's observe. We see that we have the final velocity. We know the final velocity is equal to 0 meter. We know what is our altitude, which is our y. Okay, we know what is our acceleration. So from the 3 given information that we know, we can see that we're going to use this formula to apply to get our initial velocity. So we say vy, it's given, this one is given, and then the initial velocity in y is a unknown plus 2 a in y and as well y. So this is given, I is given, so the only unknown is this. So every time you use a formula, one of the variable must be a unknown. So therefore, as we say, this one is equal to 0, this one is equal to minus 9.8, and then the I, because we say it's going to be changed in meter. Okay, and then here we're going to get your initial velocity in y. Once you get your initial velocity in y, again you have another information, which means you have to check for another equation which can apply so that you can get the maximum time. Can you see the projectile time? And then in order for you to get your projectile time, you can apply another equation as well. And then you come here, you say we're still in y, and then it's going to be Vy is going to be equal to V initial, the one that we got, plus acceleration in y and time. And then remember, the final velocity speed in y is equal to 0. The initial, we got it from the previous equation. The acceleration, we got it, it's minus 9.8 always. And then the unknown will be the time. Once you got the projected time, now you can calculate, you can apply this formula. V, velocity initial in x, okay? The time plus 1 over 2, the acceleration in x, and the time squared. Remember, we said the acceleration in x is equal to how much? To 0. And therefore, this part already will fall down. Okay? So we know what's going to be our time. We know what is our velocity in the speed in x, and automatically we create our x. Can you see that? Okay? So those are the most important parts, key you can apply around when it comes to question 2, but you're going to see it under the memo. But the most important information, as I say, is for you to collect, you know, that the projected time is going to be equal to, at the projected time, my y is equal to 0, and then the final velocity is equal to 0. And then you can see, another information is that the velocity is constant, therefore the acceleration in x is 0. And then in y, we say acceleration in y is going to be equal to the gravitational, but we put a negative because we are going down. Okay? So those are the information that we need to keep here. Okay? So let's have a look on question 3 and see what the difference between the two. Okay? So remember with question 2, okay, with question 3 here, someone is on the top of the building. Okay? And then this person throw a stone. Can you see? So there is a force, there is an initial speed. So there is a force, someone threw a stone from a specific point. Can you see? So therefore, more often when you're doing our calculation, when an object was thrown, once an object was shot, our x and y axis will become here. Can you see? So you have your x and then your y axis. But the initial I, which means this y here is going to be the initial I. Can you see? Because we didn't start at 0, we start at 45 meters. This is going to be the initial y, the initial distance of I. Can you see? It's like I'm having an x and y axis. This is my 2D. But remember, I didn't start from 0. But from this case, I start already from a specific I. So which means my x become here, my y remain there. So this space here, it's our initial I. Can you see? Because we didn't start from 0, 0. Can you see? Our intersection is not 0, 0. Our intersection become what? X is 0, but y is 45 meters. Okay? So this I here is going to be the initial. The reason why is because of this. Okay? So therefore, they give us this initial speed, but they say the stone was thrown at a 30 degrees. So we have an angle that is given here is 30 degrees there. Okay? And I said this I here is our initial I. Okay? And therefore, and they say this initial speed, the initial speed is 30 meters per second. Okay? And then the I of the building, and then you say this I is going to be the initial I. Okay? Reason why we explained already what is the reason. Okay? So therefore, as you can see, because of the speed, we're going to have a speed in x and the initial speed in y. So what is going to be our initial speed in x? It's going to be equal v0, because remember this is adjacent to the angle, so it's going to be cosinus of 30, and as well for the y, it's going to be VO sine of dt. So we know already what is our initial speed in x and our initial speed in y. So what next now? But the question they say, how long is the stone in flight? Remember we say, what did we say about the projectile time? We say the projectile time is the maximum time required for the stone when it was thrown until it reached the ground. And then we know that at this point, our final velocity is equal to 0 meter per second, and as well our I is going to be equal to 0 meter. So those are the most important parts when you are dealing with a projectile time. How long the stone will be in the air from the moment that I throw it until it reaches the ground. That's the projectile time. At the projectile time, the I is going to be equal to 0. Our final velocity is going to be equal to 0. Always. Okay? And therefore, now we have to calculate that time. Okay? So which formula we can apply now? Okay? So we come here. We have this equation from the foregiven equation. We have the y is going to be equal to initial velocity in y, the time plus 1 over 2a t squared. But remember, this y, our y, is going to be equal to what? Plus the initial I. So I'm going to come here, I add y initial, because remember I have already an initial I. So which means my I is going to be the final plus the initial. Remember, displacement. We talk about the displacement. It's like this one is the final I. But I was already given an initial height. So I must come here and add the initial I to it, so that I know that I start from the initial I plus the initial I. This is the final I. Okay? So that's basically what you need to do. You add that initial I. So which means every time you are given the initial I, from when you are throwing a stone, you must consider it, you add it into your equation. And then remember, what did they say? The final one is going to be what? Y is equal to 0 at the projective time. Okay? And then this velocity in y, we have calculated already. Okay? Acceleration in y, what do you say about it? It's going to be minus 0.8. Always acceleration in y. And then the initial velocity, I is going to be what? 45. Okay? So you're going to be dealing with an equation in second degree, whereby we're going to calculate T1 and T2. Okay? And then you're going to take the T that is a positive, you're going to see it under your memo. So this is just an important formula that you need to keep in mind. Okay? And then everything else that is just under the memo. The information is just that when you throw something from an initial I, when you're applying your equation, you need to add that initial I. And that is about question 3. Anything else is under your memo. So let's have a look now on question 6 and see what is going on question 6. And as I said, the concept is the same. We're still under the projective time, under the projective object, and the concept is still going to be the same. Okay? So let's have a look on question 6. So question 6, you can see that they give us a shell of a fire is on horizontal velocity. Okay? Okay? And it's on the top of a 60 meter cliff. The shell strike at this distance. Can you see? So we have this fireworks was that standing on the top, and then when it fall down, it went to this specific distance, and then the swimmer must calculate the initial speed. Okay? But remember, already they give us the initial speed is in x. Is in x. And you see, our initial is in x, which means in y we don't have any initial speed. So already you can come and say the initial speed in y is going to be equal to 0, because we don't have any speed in y. The speed is only in x-axis. Remember when we were working with force, if I come here, I have a vector, and this vector is already in the x-axis. in the y-axis is equal to what? Is equal to 0. Okay, so that's basically what we are going to do with this question. So we take it, we observe that in y we don't have any velocity. Okay, we don't have any speed. Okay, so if we don't have any speed in y, but we have the I. Okay, so we can here. The question that was asked was to find what is the initial velocity. Okay, and then we say that initial velocity is going to be equal to the velocity in x, because the initial velocity will be equal to the velocity in x. Okay, so we come with this equation here. We can see that we have our I, okay, and then we have our x distance that was given as well. Okay, then we can see that here we are dealing just with I. We want to find out what's going to be our initial velocity. So we take our y, it's going to be equal to v initial y time plus 1 over 2. Acceleration is y t squared. Okay, because here there is no any force that was applied. There was no any acceleration that was applied. The object just fell itself down. It was like this, and then after a specific time it fell down. Okay, so what happened here? Now we have the y is going to be given by 800. I think it's 80. It should be 80. And then our initial in y, what did you say, is equal to 0, because the vector is only facing in the x-axis. Therefore in y we have 0. And then our acceleration here is going to be how much? Minus 9.8. We say always the acceleration in y is going to be 9.8, and therefore we're going to get our projective time. Okay, after getting our projective time, now we can take again our equation in x-axis is going to be vox. Okay, the time plus 1 over 2, the acceleration in x, the time. And then we say the acceleration in x is always equal to what? It's always equal to 0. And therefore already this part, because this part is 0, we don't consider it. So we know that x is equal to 1,200, and then the initial velocity in x is going to be equal to the given time that we got. Then we're going to get our initial velocity. And then we said this initial velocity in x is going to be equal to the initial speed. Okay, so that's basically what's going to happen. Once you have get this, now you can do the calculation of your what was that question they say? What is the speed of the shell if it hits the ground? Okay, and then remember, as I said, it's all about your Pythagoras. The speed is going to be equal to what? The speed in x squared plus the speed in y squared. Okay, because we're in the 2D, we're always going to have your Pythagoras. Okay, so in x we know already what is our value. So what we just miss us, we just calculate the final velocity in y. So the final velocity in y is going to be the initial velocity. The initial velocity, we said how much? It's 0 plus the acceleration in y time. Okay, and then therefore automatically this one is 0. Then we're going to have a minus 0.8 times the time that we got there, and then we're going to get our equation. Okay, so we can see that the only difference between the three, we see already observation. Here it was shoot, it was throw, but here it was on the shell, so it was going to fail itself. Okay, this shell is fire. It's fire, then you can see that the speed it in the x-axis, therefore in the y it's going to be equal to 0. So that's going to be the three difference between the three questions. Okay, on the next video we are going to discuss about the range when you have a ball that is kicked from the low level, or if you are playing basket. So which means that concept is going to be the same apply when you're playing basket and something like that. Okay.